A kata is something you practice, not something you watch. Read the lesson, write the code yourself, then review what you wrote. This video is the reference you come back to afterwards. A model can produce this code in seconds, and the reason to write it by hand is to keep the judgment that tells you whether the code is any good. Writing a click handler in React takes about 10 seconds, and almost nothing about it is what it appears to be. The handler you passed is not attached to that button. The event object you receive is not the browser's event. This lesson covers the handlers you will actually write: clicks, mouse moves, form submits, and keystrokes, and then goes under them to what React is really doing with the browser's event system. There is one mistake near the start that everybody makes exactly once, and it is worth making on purpose. The click handler is the one you will write most often, and the shape of it is worth getting exactly right. You hand the onClick property a function. You do not call it. That distinction is the single most common error in React, and it does not fail the way you expect. Calling the function there runs it while the component is rendering and hands React whatever it returned. So the thing happens immediately once and then never again when you actually click. The playground at the end of this lesson has that mistake in it running, so you can watch it happen. The counter on screen is the working version. Every click adds 1, and the number above the button is state, so React re-renders and the count you see keeps up. The handler is an arrow function, which is what you reach for whenever the thing you want to run needs arguments. React calls that arrow function on the click, and the arrow function calls what you actually wanted. Clicks are one member of a family. React gives you mouse move, mouse enter, mouse leave, mouse down, and mouse up, and the names all follow the same rule: on, then the event name in camel case. Enter and leave are the two worth knowing properly. Unlike the older mouse over and mouse out, they do not fire again as the pointer crosses into a child element, which is the bug behind most hover effects that flicker. Move your pointer over the box on screen and the two numbers under it follow. The handler reads two properties of the event, client X and client Y, and puts them into state. Those coordinates are relative to the visible part of the window, not to the box and not to the page. So scrolling changes them without the pointer moving at all. Every mouse move fires this handler, which is dozens of events a second, and each one sets state that is fine for two numbers on screen, and it is the first thing to look at if a mouse handler ever makes a page feel heavy. Forms need two handlers. On change fires as the user types, and on submit fires when the form is submitted. There is a detail hiding in the first one. Reacts on change is not the browser's change event. The browser fires change only when the field loses focus, which is far too late to be useful. React fires on change to the native input event instead, so it fires on every keystroke, which is what everybody assumes it does. It is one of the few places React quietly renames something to match what people expect. The form on screen has two fields and a submit button, and pressing submit puts the values in the panel underneath rather than reloading the page. Prevent default is what buys that. A form submit is a navigation as far as the browser is concerned, and unless you say otherwise, the page goes away and takes your application state with it. Notice also that one change handler serves both inputs. It reads the field's name of the event target and uses it to update that key in the state object, which is how a form with 12 fields still has one handler. Keyboard input comes through key down, key up, and key press. Reach for key down. Key press has been deprecated for years and never fired for keys that do not produce a character, so arrow keys and escape went straight past it. The event carries the key itself as a string in the key property. That is the character for a printable key, and a name like enter, escape, or arrow down for the rest. The box on screen reports the last key it saw. Type into it, and the line underneath names the key, one word exactly as the event reported it. Try the keys that are not characters. Shift and the arrows come through with names rather than symbols, and that is the property you compare against when you want enter to submit something or escape to close it. Every handler is passed one argument, and the list on screen is the part of it worth memorizing. Target is the element the event started on. Current target is the element whose handler is running, which is the same thing until the event has bubbled up from a child, and then it is not. Prevent default cancels what the browser would otherwise do. Stop propagation stops the event traveling further up. And the event-specific properties key for the keyboard, client X and client Y for the mouse carry the actual payload. One thing you may read elsewhere that is no longer true: these objects used to be pooled and reused, and you had to call persist to keep one. React 17 removed that. This lesson runs React 19.2, so the event object is an ordinary object that you can keep. 4 patterns on screen, and the first one is the error. Calling the function runs it now. Passing the function's name hands, react something to call later, which is what you want when the handler needs no arguments. The inline arrow function is what you want when it does, because the arrow closes over the argument and defers the call. And the fourth takes the event as a parameter, which you need whenever you're about to call prevent default or read a value of it. Almost every handler you write is one of those last 3. Here is the part that changes how you read all of it. React does not attach your click handler to that button. It attaches one listener per event type to the root container, the element you handed to create root when the application started, and nothing else in your tree has a listener at all. So when you click a button, the browser's own event bubbles all the way up to the root. React catches it there, works out from its own tree which component that element belongs to, wraps the native event in a synthetic one, and calls your handler. Then it walks up its own component tree, calling any parent handlers, which is React reproducing bubbling rather than the browser doing it. 2 consequences fall straight out of that. Thousands of rows cost you 1 listener, not thousands. And if some non-React code between the button and the root calls stop propagation on the native event, the event never arrives at the root, and your React handler simply never runs. That one is worth remembering the first time a handler goes silent for no visible reason. Pass functions to handlers, do not call them. Use an arrow function when you need to pass arguments. Call prevent default in any submit handler or the page reloads. The event you receive is React's synthetic event, consistent across browsers, and since React 17, no longer pooled. And underneath the whole thing, there is one listener at the root of your application, not one per element, which is the fact that explains the rest. This first version has the mistake running, so you can see what it actually looks like. 2 pieces of state and 2 buttons. Look at the first buttons on click. Alert is being called right there in the middle of rendering. The alert fires the moment this component renders before anyone has clicked anything, and what gets handed to onClick is alert's return value, which is undefined. So the button does nothing at all when you click it. The second button is the interesting part of the demonstration. It only forces a re-render, and every time you press it, the alert comes back, because rendering is what triggers it. A handler that fires when you are not clicking and ignores you when you are is the signature of this bug. The fix is small enough to miss. The alert is now inside an arrow function, so what onClick receives is a function to call later rather than the result of calling it now. Nothing fires on render. The click fires the alert and only the click. The second button is unchanged and still increments the counter, and the count above it now goes up on click rather than announcing itself on every render. If you take one line from this lesson, it is this one. The last variant puts all 3 families in one component so you can see them side by side. It opens with 4 pieces of state, a click count, the last key, an object holding the form fields, and the submitted result, which starts as null and is the thing that decides whether the result panel renders at all. Then 2 handlers defined above the markup. Handle submit calls prevent default first, stores what was submitted, and clears the fields. Handle changes the one worth studying. It reads both name and value of the event target and writes back a new object with that one key replaced, so the same 3 lines serve every input in the form. Below that, the markup in 3 sections. The click section increments and resets a counter. The keyboard section reads the key property on key down and shows it. The form section wires each input's name and change handler and hangs the result panel off whether submitted has anything in it. 3 event families, 4 pieces of state, and the shape of nearly every form you will write. The model worth keeping is short. Your handler is not on the element. There is one listener at the root of the application. The browser's event bubbles up to it, and React works out from its own tree whose handler to call, then does the bubbling itself. Everything else follows from that. Why the event object is React's and not the browser's, why one listener serves 10,000 rows, and why stopping the native event somewhere in between makes your handler go quiet. Write the handlers first, then go back and read that paragraph again. The kata is the part that matters. Open the lesson, write the code yourself, then read back what you wrote and judge it. The link is in the description, and that practice is what keeps the skill yours.